Hello and welcome to another video. The ultimate goal of this project is to develop an automatic bubble sheet grader. I'll be demonstrating some of the most essential methods in OpenCV. We'll explore the impact of each method and its parameters in real time. Let's begin. After clicking the Show Image button, we'll use OpenCV to display a loaded image. First, we use ImRead with the file path to load the image. Then we create a window named Image to display it. We can also resize the window and move it to a preferred location. Finally, the window remains open until we press a key, in this case the Q button. For the next method, we'll resize the loaded image using the Resize function. The inputs include the source image, the target size, fx and fy, which control the horizontal and vertical scaling. The interpolation parameter determines how the new pixel values are calculated. There are several options available, so we can experiment to find the best settings for our specific needs. Next, we can apply adaptive thresholding to separate the background pixels from the foreground. The source should be the grayscale version of the input image. The max value is the highest pixel intensity to which our pixel values will be mapped. The threshold type determines whether the foreground pixels will be mapped to white or black. Adaptive method decides how the threshold value is calculated for different areas of the image, making it better for varying lighting conditions. Block size is the size of the area around each pixel used to calculate the threshold value. Larger block sizes consider more pixels. C is a constant subtracted from the calculated threshold value to fine-tune the result. Our next goal is to extract horizontal and vertical lines from our thresholded image. To extract vertical lines, we start by creating a thin vertical line structure and applying morphological operations to the image. So when we erode the image, we slide this vertical line structure over the image and keep only the minimum value of the pixels under the line. This operation preserves only the areas where all the pixels under the line are white, which highlights the vertical lines. We can use a slider to adjust the height of the line structure and choose how many times we want to erode the image. Eroding multiple times further reduces the white areas, making it easier to separate the lines more clearly. After erosion, we can apply dilation. During dilation, we slide the structuring element over the image and keep the maximum value of the pixels under it. This operation reserves some of the effects of erosion, helping to enhance and connect the lines. To extract horizontal lines, we use a similar approach but with a horizontal line structure. Next, by pressing the Define Contours button, we can detect and outline shapes or boundaries in an image. The method looks for areas where intensity of pixels change sharply. It traces the edges of these areas and creates a contour around them. The source is the image with vertical and horizontal lines. The mode defines how the contours are retrieved. For example, external will only retrieve the outermost contours, ignoring any nested ones, while tree would retrieve all the contours and their relationships. Method specifies how the contours are approximated. For instance, approxsimple will store only the essential points of the contour, simplifying the shape, while approx_none will store all the points along the contour. After finding contours, we sort them top to bottom, left to right. Our next object is to detect circular regions of the image in each contour. We can use simple blob detector to achieve this. Filter by area enables filtering blobs based on their size, and min area specifies the minimum size of blobs to detect. Filter by circularity allows filtering blobs based on their circularity, and min circularity defines the minimum circularity a blob must have to be detected. A value closer to 1 means the blob must be very round. Filter by inertia enables filtering blobs based on their inertia ratio. Inertia measures the ratio of the minor and major axes of a blob. We draw the detected blobs, but as you can see, some blobs are missing. So we try to adjust settings to find the maximum number of blobs. But it can be challenging to adjust the settings to find all of them. One way to address this issue is to calculate the median distance between the rows and columns of the circles. If we notice that some blobs are missing, we can manually add them. That's what we've done here. So if everything is fine, we can go and check the user answers. Therefore, the goal is to determine which bubbles are filled based on their pixel values. For every bubble in the image, we create a mask that isolates the area of the circle from the rest of the image. Within this masked area, we count the number of white pixels, and we compare it to a preset threshold. If the number of white pixels exceeds this threshold, the bubble is considered to be filled. To compare the results, we randomly generate the correct answers for each question and compare it to the user answers. The results are then organized into a data frame for easy analysis. That's it for today's video. Subscribe to stay updated with more content in the future. Thank you.